Welcome back. Welcome back. Another Explore in Chemistry. Yes, don't forget to comment, subscribe, and comment, subscribe, and also don't forget to like. So let's go with another question. Yeah, that's my third question. So if you see very much properly, the question is saying to say at 40 degrees Celsius, the value of Kw, which is constant ionization of water, is 2.92 times 10 exponential negative 14. Calculate the hydrogen, or which means concentration of hydrogen ion and concentration of hydroxide ion in a pure water at 40 degrees Celsius. And also the second question is saying to say what is the pH of pure water at 40 degrees Celsius. And also the first question, which is totally more like a little bit different from what we have been given or what is on top. If the hydroxide ion concentration in a solution is 0.10, which is molar, what is the pH at 40 degrees Celsius? So nothing to worry about this. So our main concept here, we have to write our data here. We have to write our data, of which our data here is saying to say we have got our Kw, which is constant ionization of water, 2.92 times 10 exponential 14. In the same question, we have also to calculate the concentration of hydrogen ion and also the concentration of hydroxide ion. People, this is a simple question. Don't worry, take time. It's a simple question. This is a simple question of which you have also to make sure that we go through together without failing. So, if you see very much properly, according to what I've been given in the question, I've got Kw, which is 2.92 times 10 exponential negative 14. So, I've been asked to calculate hydrogen, concentration of hydrogen ion. We've been asked to calculate the concentration of hydroxide ion. So what's going to happen here? First of all, you have to write the dissociation, or let me say the expression of Kw, or the expression of both hydrogen ion and oxide ion, or self-ionization of hydroxide and also hydrogen, of which it is like this: hydrogen ion, which is concentration of hydroxide ion, times concentration of hydrogen ion as only positive, that symbolizes an acid, and also I've got concentration of hydroxide ion, that symbolizes a base. This should be equal to what? To Ka to Kw, which means they are dissociating in what? In water. Kw, they are able to dissociate in what? In water. So everything here is coming from this equation, or this equation what I've written here is coming from this side. You say hydrogen ion plus hydroxide ion, that's self-ionization of water. Yeah, I don't want to explain a lot of things here. That was just an experiment that was being done in 1990s, of which you have to say in 25 degrees Celsius of water there is 10 million molecules, and also one concentration of hydrogen ion and one concentration of hydroxide ion. That's how they have to deliver the pH ranging to scale of 14. And this is hydrogen ion plus hydroxide ion as only negative, These are able to produce what? H2O. Right? Or H2O is able to dissociate, or let me say, blacken down into what? Into hydrogen ion plus hydroxide ion. So what is happening here is this. If I'm able to write my Kc expression, or equilibrium concentration, this is Kc is equal to, we know to say it's a product over what? Reactant. So we say, if you see very much properly, this is in form of, it is in liquid state, this is in aqueous state, this is in aqueous states. So it is what? Hydrogen ion, product over reactant, and also times hydroxide ion, divided by H2O. Now, here it is. I cannot put the concentration of water, no. Because water, it is heterogeneous state. It is in heterogeneous states. I have to put in the substances or the compound that are in what? In homogeneous state. So I have to what? To exclude water there. I have to exclude water and remain with what? Kc is equal to hydrogen ion and also hydroxide ion. And this one tries to say, if I have to remove water here, Kc, which I have removed water, and remain with Kc, which is a concentration equilibrium, that symbolizes to say, everything here that we are trying to do here, it was underwater. This concept was self-ionization of what as water. So in this case, I'm going to put K what? Kw is equal to concentration of hydrogen ion and also concentration of what? Hydroxide ion. Right? Yes. So here we go. That's where these things, this equation, this chemical equilibrium, or let me say chemical expression, came from. So here we go. So we say concentration of hydrogen ion and also concentration of hydroxide ion is equal to Kw, of which concentration of hydrogen ion, what's a Kw? A Kw, it is what? 2.92 times 10 exponential 14. So what's going to happen here, which means concentration of hydrogen ion times concentration of hydroxide ion as only negative, we have to square it so that we know the value of hydrogen ion and hydroxide ion. And please, as you are doing that, you should put them in brackets to avoid those conveniences. So therefore, concentration of hydrogen ion and also concentration of hydroxide ion is equal to, if you get your calculator here, you punch your calculator, you say the square root, open 2.92 exponential negative 14. What's your answer? It's what? Yeah, that one. So you're going to like to say only 1.7 times 10 exponential negative 7. Yeah, just to in one decimal place. Yeah, this is what? Molar. That's the concentration of them. So therefore, concentration of hydrogen ion is equal to concentration of hydroxide ion, which is equal to 1.7 times 10 exponential negative 7 molar. So finish. That's our concentration. Again, we've been taught to calculate the pH. If I'm not mistaken, we've been taught to calculate the pH. What is our pH of the pure water? So what's going to happen? We've been taught to calculate the pH here. So far so good. The pH are going to use the hydrogen ion, not hydroxide ion, of which one and the same. So if you like your data here, your hydrogen ion is equal to 1.7 times 10 exponential negative 7. Right? Now, the pH you don't have. So what's going to happen, I'm going to say, here's the formula that you have to use. You say, the pH is equal to, H is for hydrogen ion, concentration of hydrogen ion, which is this one, is equal to negative log concentration of hydroxide what? Hydroxide ion. Hydrogen ion, sorry. We're talking about hydrogen here, that's pH, that's hydrogen ion, which is this one, of which you say pH is equal to negative log, what's the concentration of hydrogen ion that you have been given? Is 1.7 times 10 is equal to negative 7. Please, people, note that this, if you see these brackets, this means these are brackets, yeah. So if you see these brackets, that symbolizes to say it's a concentration. So try to punch again. You say negative log, open brackets, yeah, 1.7 exponential negative 7. A bit sorry in terms of calculations. Yeah. Negative log, open brackets, 1.7 exponential negative 7. Cross brackets. Please, you should be crossing all the brackets here. Sometimes you have to be very much careful in terms of calculating. What's your answer? It is 6.76. So my answer here, I will just say the pH that I've been given is equal to 6.8 if I round off to 1 decimal place. That's my what? My pH, which is similar to very much near if you round off, that's the pure water. Because the pH, it is the pH of pure water to 7. But if you round off to 1 decimal place, if you round off to 1 significant figures, you're going to find to say you're going to have what? 7, which is the pH of pure water. Yes. What's our next question? Our next question I've been told to calculate, that's the last question I've been told to calculate, that's question 3. We've been told to calculate the concentration of hydroxide ion. You have to be very much careful writing the data here to recognize what you have been told to calculate. If the concentration of hydroxide ion as only negative is 0.10 molar, what is the pH? What is the pH? You don't have. So what I'm going to do there, people, simple as that, you're going to say, there's this formula that you have to use. Remember, it is OH. So OH, of which are symbolized to say it is POH. That's also symbolized to say it is a base. Right? This concentration is coming from the base. So here's the formula you say, POH, right, is equal to, that's the same formula, that's the same formula, but here we are putting pH, we are going to put POH. POH is equal to negative log, then the concentration of what? Hydroxide ion. Right? And I say POH is equal to negative log, what's the concentration of hydroxide ion? 0.10. Then POH is equal to, get your calculator here, you punch again, you see, negative log, open brackets, 0.10. What's your answer? It's 1. So the POH there is what? It's 1. Right? So that's a POH, it is 1. Now what is a pH? So there is this formula that you have to use. You say pH plus POH should be equal to what? 14. That's a ranging scale. We all know to say less than 7 as an acid, above 7 as a base. So what is our pH? It's 1 plus POH is equal to 14. Correct the right terms there. Say POH is equal to 14. When 1 comes here to be negative 1, of which to be what? POH is equal to 14 minus 1, that is what? 13. So that is the pH. That's our last question. Thank you very much. Thank you very much for your attention. Don't forget to subscribe, comment, and also like. Comment if there is something wrong so that we can keep on working on it. Thank you very much. Thank you very much. Stay blessed.